Let's talk about Project 2, Lesson 9. Automotive engineers use the equation S equals the root 30 FD to study the relationship between a vehicle's speed S in miles per hour and its stopping distance D in feet after applying the brakes. In this equation, F is the coefficient of friction, which depends in part on the condition of the road. Determine the coefficient of friction to the nearest tenth for dry pavement. Okay, so let's first consider the equation at hand, which is S equals square root of 30 times F times D. So this is telling us that if we want to know S, the stopping distance in feet after applying the brakes, we take the square root of 30 times F, the coefficient of friction, times D, distance in feet. So F, the coefficient of friction, changes depending on the condition of the road. For example, imagine you're driving and you slam on your brakes when you're in the mud versus on a normal road versus on a dirt road or maybe even an icy road. Obviously, the time it takes you to come to a complete stop is going to differ depending on which of these roads you might be driving on. Now, we are given stopping distances on dry pavement, and we're giving sets of speeds and distances that go together. And we're being asked to solve for F, the coefficient of friction. So I can choose any one of these pairs from the table. I would just pick the first pair because it's the smallest numbers to deal with. So speed here is 10, so plug in 10 for S. Distance is 4.2, plug that into distance. And from there you can solve for F. Now, because this is all for dry pavement, no matter what pair you pick, you should still end up with the same F, and I encourage you to double check that in your calculations. Question 2. Predict the stopping distance to the nearest foot for a vehicle moving at 65 miles per hour. So you found the coefficient of friction in the previous question. So use that F here, and then we're told that the vehicle is moving at 65 miles per hour, which is our speed. Use that information to predict the stopping distance to the nearest foot for this vehicle. Question 3. If the coefficient of friction on wet pavement is 0.4, what is the effect on stopping distance given the same speed? Okay. We'll compare this to what your current friction is. So this is the F that you used in both questions 1 and 2. What is its relationship to 0.4? So the number of F that you're currently using, think about how that relates to 0.4. Now, what do you have to do to the distance in order for the speed to be the same? And consider just the reasonableness of your answer. So remember before we were talking about dry pavement, and now we're talking about wet pavement. So I bet you can predict without even looking at numbers the effect on stopping distance. Is there more or less friction on a wet road than on a dry road? Imagine driving in your car. Imagine slamming the brakes on a wet road versus a dry road. Which one do you think will take the car longer to come to a stop? So consider all these questions when answering question 3, what is the effect on stopping distance?